Welcome to 3.3. We finished up 3.2, figuring out that you can have fractional exponents. You can have less than just multiplying by half of a year or anything like that. We looked at this idea right here, 1.05 to the 1/2% being 1.05 the square root. We even talked about 1.05 to the 3/4 power, and how that is the same thing as the fourth root of 1.05 cubed. So we looked at that kind of idea right there. And now, with Carlos, who knows that he can calculate the amount of interest earned on an account in smaller increments than a full year, he's actually curious about how much money he would have an account that each month earns 5% annually with an initial deposit of $300. So he starts by considering the amount of the account each month during the first year. He knows that by the end of the year, the account balance should be $315 since it increases 5% during the year. We need to complete the table showing what amount is in the account each month during the first 12 months. So kind of the way that we'll do that, we've seen the formula looking at the number of jumps before. We've talked about this formula with the number of jumps for a geometric equation, which is this exponential formula, where we count the number of jumps, which in this case are going to be 12, and we take that number of jumps and put it right here as the radical, so I'm going to do 12, and in here, I'm going to put the final divided by the initial, or I could also put the interest rate in there, which is going to be the same thing as the final divided by the initial. It's 1.05. So for each time that we make a jump, we're going to multiply the previous number by the 12th root of 1.05. So, for example, I will multiply 300 by the 12th root of 1.05. And that's, as we talked about last class, that's about 1.004. But I'm going to use the exact number, and I'm going to multiply that by 300. And that should give me $301.22. So every time I'm multiplying by the 12th root of 1.05. Okay? And then I'll do it again. I would multiply that, 301.22 times the 12th root of 1.05. And that should be 302.44. Multiply it by the 12th root of 1.05 again. 303.68, and so on. But you guys, I want you to go ahead and finish out the rest of this table. I'm not going to, but I would like for you to. If you are confused, some of your calculators will have this a little bit differently. You might have to enter it in as a fractional exponent, say 1.05 to the 1/12th power. You may have to put that in your calculator and then multiply that by the previous number, but you should continue this till all the way your very final number should, when you multiply it, should give you 315 exactly. So go ahead, pause the video, take a couple minutes to fill in the rest of those. If you are confused, please ask a classmate on how to enter those fractional exponents or the radical, the root, the 12th root, into your calculator. Okay. When we look at what number you multiplied the account by each month to get the month's balance, we should look at this number. When we plug that into our calculator, what do we actually get just by itself? And that should be about 1.004 is what we're multiplying by each time. So approximately times 1.004 times 1.004, and so on for the rest of it. So if you were having trouble as well with the 12th root and you need me to show you kind of how to do that when we get back, or when I get back, we can go through that then, but you're multiplying by 1.004. So Carlos knows the exponential equation that gives the account balance for this account on an annual basis is the annual kind of A here, that's the annual amount, is equal to 300 times 1.05 to the t power. Based on his work, that t power also is the number of years generally. Based on his work finding the account balance each month, Carlos writes the following equation for the same account, where now he's got 1.05 to the 1/12th power and it's raised to the 12t power. So what you need to do is verify that both equations give the same result using the properties of exponents and explain why these two equations are equivalent. So if we look at this right here, we're basically saying, why is this the same as this? Okay, why are those two things the same? Well, we know what an exponent is, right? We know that an exponent is just repeated multiplication. Tayson has brought that up a couple of times, and I appreciate that because we're just saying it is this thing inside of the parentheses multiplied by itself 12 times. And when we multiply parentheses, like when we multiply bases, sorry. So if we go 1.05 to the 1/12 times 1.05 to the 1/12 times 1.05 to the 1/12, what we're doing is we are actually going to be, 1/12, we add the exponent. So it's this is the equivalent thing as saying 1.05 to the 1/12 plus 1/12 plus 1/12, all up there in the exponent. Another way to think about that is since exponents are repeated multiplication, we know that multiplication is repeated addition. So if we have 1/12 plus 1/12 plus 1/12 12 times, we will actually get 12 twelfths, which is just 1. So what we're actually doing is we have 300 times 1.05 to the 1/12, and what we've done is we've actually taken that exponent and we've multiplied it by 12t, because when you raise one exponent or a base with an exponent to an exponent, you can multiply those exponents together. And just because multiplication is repeated addition, right? So when we multiply those two things together, we've got 300 times 1.05, 12 over 12t, and then that is just the same as 1.05 raised to the t, because 12 over 12 is just 1. So it's 300 times 1.05 to the t power, because 12 over 12 is just 1. So that's how we could verify that, just doing a little bit of multiplication up there, some repeated addition, right? So the question in number 4 says, what's the meaning of the 12t in this equation? Now, the meaning of that is if this is the interest rate for 1 month, and we know that t is number of years, we have to say, okay, how many years are there in one, or how many months are there in 1 year? There are 12 of them. So we're saying that 12t is to say there are 12 months in 1 year. 12 months in a year. That's all we're trying to represent there. Okay. Now Carlos shows his equation to Clarita, and she suggests his equation could also be approximated by a equals 300 times 1.004 to the 12t power, since 1.05 to the 1/12 is approximately 1.004. Now Carlos replies, I know the 1.5 in the equation a equals 300 times 1.05 to the t means that I'm earning 5% annually. Now let's dissect that for just a second. When we've got 1.05, if we broke that down, that's actually saying 1 plus 0.05. Now this 0.05, that's the percentage that we're dealing with. This 1 represents the amount that we started the year with. So we could also say the equation is 300 times 1 plus 0.05 raised to the t, because then you can see this is the entire last year's end value, and this is the percentage that we are gaining for interest in the following year. It's just simpler to combine them as 300 times 1.05 to the t, so we just go ahead and do that. But now is the question Carlos asks, but what does the 1.004 in your equation mean? Now, if we think about that, we could say, okay, we're going to answer Carlos's question here and say, what does that 1.004 mean? Well, if the 1.05 meant we're earning 5% interest annually, then 1.004, because remember, this is also monthly, we could think about it like this. It's 300 times 1 plus 0.004 to the 12t. right? Because there are 12 months in that year. So if we're thinking about that, here's the previous year's balance, or the previous month's balance even. This is our new percentage. Now, with 0.05, we know, okay, just move the decimal twice and that equals 5%, right? But with 0.004, how do we know what percentage that is? Well, we're going to do the same rule of move the decimal place twice, and it'll just be 0.4%. So what that's telling us is that there are 0.4% interest being paid to us each month, or being paid to Carlos each month. So that's what that 1.004 means, is that there is 0.4% being interest being paid at the end of each month. Now, the properties of exponents can be used to explain why 1.05 to the 1/12th power raised to the 12t is equal to 1.05 to the t power. Here are some more examples of using properties of exponents with rational exponents. For each of the following, and remember, rational just means it can be represented as a fraction. For each of the following, simplify the expression using the properties of exponents and explain what the expression means in terms of the context. I'm going to do one of these with you right now, and then I'm going to have you pause the video, and I'll actually release the second half of this video partway through class so that you have to actually try to work on these a little bit, right? So think about what we talked about previously in this lesson with adding exponents, with multiplying exponents, and see what you can do looking at this lesson and the previous lesson to figure out what these are. But this first one, I'll just say real quick, remember, when you have bases that are being the same and being multiplied, you can add the exponents, okay? So you can add and add. So another way to write that would be 1.05 to the 1/12th power plus 1/12th power plus 1/12th power. Okay, now if we add all those together, we would get 1.05 to the 3/12ths, but that is a reducible fraction, so we could say this is 1.05 to the 1/4th power. Okay, so that is the most exact answer you can get. Okay, I am going to pause the video here. We're going to end it actually, and you get a chance to finish these other ones. And then about halfway through class, I will put the other one up and you can check your answers. Thanks.